Let us discuss a quantitative trading strategy which is based on a t-test. So the first thing is the observation and an assumption which is often made is that the return on the stock is normally distributed. So this is an observation, and it is also the fundamental assumption which is made for use of stochastic calculus in mathematical finance. In fact, the Black-Scholes formula, which is used for pricing derivatives, is based upon this assumption. So let us recall what the return on stock is. So say you are given a sequence of share prices for AB Corporation. So the sequence is stock prices, say S1, S2, S3, S4 and so on. So this is a running stock price. So say 6-month history of AB Corporation. From there you form the return on stock. So you have S2 minus S1 over S1. So you take difference between these two terms and divide it by S1. Then S3 minus S2 over S2. So difference between these two terms and divide by S2. Then S4 minus S3 divide by S3 and so on. So this is the return on stock. So if this has n observation points, this will have n minus 1 observation points. So from this sequence you have formed a new sequence. And the fundamental assumption is that this new sequence is normally distributed. So say you have two corporations, you have Corporation X and Corporation Y. And obviously we want to invest in the corporation which gives us higher return. So to find out if the return is statistically different in the two populations, so you have return on stock of X and return on stock of Y. So you want to decide in which you should invest. So the mean of these two should be statistically different. So you want to find out the return is statistically different in the two populations. So therefore you use a t-test. Now first thing is that this t-test is used on normally distributed populations. So this is a normally distributed population. So you can use a t-test on the return, but you cannot use the t-test on just the stock prices, because stock prices are not normally distributed. The return on stock price is normally distributed. So you have to use the t-test on normally distributed populations. So once you use the t-test, it will give you a confidence interval, and we will come to this when we run the t-test in R. So the null hypothesis is that the mean of these two populations is the same. So once you run this t-test, it will spit out a confidence interval. So if the confidence interval contains 0, then you accept the null hypothesis. That is, the mean of population X is same as mean of population Y. Now if the confidence interval does not contain 0, you reject the hypothesis. In that case, you say that the mean of population Y is significantly different from mean of population X. So let us do this practically. So these are the set of commands which you have to run in R. So you can copy paste these commands directly into your R script and you can run it. So let us explain what these R commands are. So this X is nothing but a sequence. So this is an R command. So these numbers are nothing but percentage return. So you have taken this return and multiplied this by 100. So this is percentage return. So first point is 1.2%, 3.1%, minus 1.3%, because the stock price went down. Then positive, stock price went up, stock price went down. So you have formed these percentage returns. Similarly for stock Y, you have formed the percentage of returns. And the question you want to answer is, where should I invest? Should I invest in stock X or should I invest in stock Y? So you can just run mean of X and mean of Y. If you run mean of X, you get 0.7250. And if you run mean of Y, you get 0.5125. Now mathematically, this is greater than this 0.72 is greater than 0.51. But statistically, are these different? Because this difference in mean just could be because of some randomness of stock prices. So what you do is you run a t-test, and this is the command for the t-test. You run this in R, and immediately you get a confidence interval out. So in this confidence interval, there is a 0 in it. So since it contains 0, you can say that the two populations have the same return. So 0.72 is statistically the same as 0.51. So the difference between these two is because of randomness in the stock price values. These two values are not very different from each other. So therefore, you cannot prefer one over the other. Now you can form an algorithmic trading strategy based on this. So what you can do is you can set a minimum return standard for your stock. So say you have set a standard of -1%. So that is the minimum return you want. And you keep running the return of stocks in the market. So you have your chosen stocks which you think you want to invest in, and you keep finding their return. So you have this sequence of returns. So for example, for stock Z, you have this sequence of returns. So see, you have -1.1 here, -2.1 here. So both these are below -1%, but you not divest from the stock Z before you run the t-test. So what you do is you run a t-test on this stock Z, and the confidence interval you get is -0.68 to 3.75. So confidence interval means that the 95% values lie in this interval. So -0.68 is greater than -1%. So you do not drop this stock. So do not drop it. Because although you have two values which are below -1%, these values represent some kind of an extreme. They do not represent the true nature. So you do not drop it. Ideally, what you should do is that you cannot have a benchmark like this, a constant benchmark of -1%. What you should do is you should have some stocks which are benchmark. So you have benchmark stocks, stocks which you think are the gold standard of the market. And then you use those stocks to define which stocks you want to buy. So say stock X is your benchmark, and then you compare X with other stocks you want to invest in. So this is the stock you want to invest in, Y, and this stock X is your benchmark. So you compare X with Y, or Y with X. It doesn't matter whether you write t-test Y comma X or t-test X comma Y. So you keep on running this test, and if you want to keep stock Y, then the confidence interval should always contain 0. So that will give you an idea that the stock which you have chosen is as good as the benchmark stock. And that is the way to use a quantitative trading strategy. So you have access to machines, and you have access to a t-test, and then you can continuously run this data and continuously divesting from stocks which do not perform according to your benchmark, and keep adding stocks which perform according to your benchmark. So you always use a t-test, which is a comparison test between two populations. Now we learn how to use the t-test. So first you copy paste from the description of the video, you open a new script, and you copy paste the commands from the description. So these are the commands. Now to run these commands, you just select them and you hit the run button, and this is the X series we have, and this is the series corresponding to Y. You have the mean of X is 0.725 and mean of Y is 0.5125. Now these two means are mathematically different. The question is, are they statistically different? So for that you have to see this 95% confidence interval. Then this is this interval here. Now if this interval contains 0, which in this case it does, that means both of them are statistically equal. Now if this interval was, say, from -3 to -1 or -4 to -1, in that case it does not contain 0. So if it does not contain 0, then these two means would be statistically different.